Okay, so today in class we went over polygons. I didn't go over regular convex or concave polygons because we already went over that in a foldable. And I also didn't go over exterior interior angles because we've also went over that. But we haven't went over finding the sum of the angle measures and to find missing measures of angles of a polygon. So the key concept is to find the measures of interior angles of a regular polygon. You can find the measure of each angle in a regular polygon by using this formula. You can use the numerator of this formula, which is the top number. You can use the numerator of this formula to find the sum of the angle measures of any polygon. So if your question's only asking for your sum, then that means that you only have to use the numerator. I'm going to go ahead and prove to you that this works because a lot of you always want to know, well, why does the formula work, or how does it work? And I don't want to just say just because. I want you to actually understand why the formula is what it is. So let's say we had an octagon, and I apologize now for my artistic ability. So here's an octagon. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So if we had an octagon and we were looking for the angle measures of each side, we don't know how, there's not a set amount of degrees in an octagon. So, but we do know how many angle measures are in a triangle. So, how many degrees are in a triangle? So, how many degrees are in one triangle? Well, you should know this. It's 180 degrees. So if it's 180 degrees, that means that I can find, if I can split my octagon into triangles, then I can find out how many degrees total are in my octagon. So if I were to split it, I would split it up 1 like this, find as many diagonals as I can. So that means that I have 1, 2, 3, 4, 5, 6. So I have 6 triangles. And if you notice that there are 8 sides, 1, 2, 3, 4, 5, 6, 7, 8. 8 sides in a octagon. So if you look at the first part of this equation, it says n minus 2. That's where the 6 comes from. N is the number of sides, so if I did 8 minus 2, I would get 6, which is how many triangles are inside an octagon. Well, I also know that there's 180 degrees in each triangle, so that's why I multiply times 180. So that's how I find the sum of the angle measures. And like I said in class, I'm not going to quiz you on how come this formula works. I just want you to be able to understand that the formula works, and I want to show you how. So here, let's go into our actual problems. These already should be written in your notebook. This is also a portion that was already in your notebook too. You can find the sum of any polygon's interior angles by measures by dividing the polygon into triangles, which is what I showed you. So I basically went over this again in the first part of this lesson, the first slide we just saw, and you have this portion already in your notebook. So I'm going to go ahead and do some examples with you. A lot of you were still in class because we kind of got a late start as far as starting this lesson goes. And a lot of you wanted to know why the formula worked, and I think it confused a lot, well, some of you. So I went ahead and made this lesson for y'all. So I'm going to do number 3. We've done 1, 2, 3, and 4 in class, but I'm going to do number 3 again, for those of you that didn't get it the first time. Find the sum of the angle measures for each polygon. Well, if I look back in my notes to find the sum, all I have to do is use the numerator, which the numerator for that formula is n minus 2 times 180. So n equals the number of sides. Well, an 11gon means there's an 11 sides. So I plug in 11 minus 2 times 180. And I do my parentheses first because it is order of operations, which is 9 times 180. And 9 times 180 is 1,620 degrees. Since it's only asking for the sum, that's all I need to do. I need to plug it in to 1,000. I only need to do the numerator. If it was asking for how much is each side, well, if the whole thing's 1,620, then I have to divide by the amount of sides, which is 11. Okay, so I want to do number 5 as well, and I'm just going to leave all the marks that I've already done on the paper or on my screen. Number 5, find the value of the variable in each polygon. Well, you need to use your prior knowledge to know that this, from here to here, is 180 degrees. So if I know that there's a straight angle right here, then I can find x by subtracting 180 minus 142. 180 minus 142 is 38 degrees. So that means x equals 38 degrees. Alright, so far so good. Okay, so what is the angle measure of each interior angle of a regular decagon? So this is number 7. That's the one I just read. I'm doing number 7 now, and I'm only doing a few problems with you to help you with your homework. Number 7. What is the angle measure of each interior angle of a regular decagon? A decagon is a polygon with 10 sides, so you don't even need to look up what decagon means. It even tells you. If it has 10 sides, it's asking for the angle measure of each interior angle. There's a difference. Here was the sum, and we only did the numerator. If it's asking for the each, that means we're going to use every part of the equation that we have, which is n minus 2 times 180 divided by n. And n is the number of sides, so I have 10 minus 2 times 180 divided by 10. Now I do my parentheses first. 10 minus 2 is 8 times 180 divided by 10. I don't know what 180 times 8 is in my head. So 180 times 8, 64. 8, 9, 10, 11, 12, 13, 14. 1440 divided by 10. I can cross out a 0, and I get 144 degrees. So here's what 144 degrees, it means that each angle inside your polygon is 144 degrees. 1,440, if each angle was 1,440 degrees, then that means that, there's no way, it's not possible. So I hope this helped you with your homework, and it helped you if you didn't understand the lesson. And this is also an example of how my flipped lessons will be. I'll go over examples with you, and you'll have to take some notes. So I hope you enjoyed this.